All right, let's do this thing. That's my hometown, FYI. Okay, cool, that's working, this is working, everything's working. So, first, I want to say that I'm extremely excited to be here in this conference in Latin America, doing a big iOS conference. When Facundo reached out to me, I was extremely excited about it, and I'm so happy that this is a reality right now. So I want to give a big round of applause to Facundo, Josefina, and everybody that organized this. So my talk is titled Working Effectively at Scale. But before I start, I want to introduce myself. My name is Francisco Diaz. I'm originally from Valdivia, Chile, which is for the locals, kind of like close to Bariloche. And I started doing iOS development in 2011. And since 2011 up to 2017, I mostly work in startups, which meant that I was like one out of like other 5 iOS developers tops in the company. And then in 2017, I moved to San Francisco, California to work for Airbnb, which is where I'm currently working at. So I want to share my experience on how this transition was. So in startups, I was like mostly used to an organizational structure that looks something like this. Basically, you have leadership on top, and then you have all these teams based on functions. So you'll have an engineering team, design, management, and then you'll have sub-teams like Android, front-end, iOS, and back-end, kind of like divided by platforms. And I was like mostly involved in the iOS team, which iOS team sounds like a big thing, but in a lot of the companies that I work for in these startups, it was kind of like this. And that's Camo, by the way, which is like he's somewhere over there. And then I moved to Airbnb. At the organizational structure at Airbnb, it's kind of different. So you have still leadership on top, and then you have all these teams mostly based on the business of the company. So most of you probably know Airbnb because we have homes, but we also have a pretty big business that is experiences. So you can imagine having an experiences team and then a homes team, and inside of this, you will have some sub-teams also based on businesses. For example, a host experience team or a guest experience team. And then you have like these platform teams that will give support to these other teams, like infrastructure. And this is where I work at right now. My team is called Native Infrastructure, and I'm part of like some sub-team inside of another sub-team somewhere around there. And since I show you this picture with me and Camo before, that was like the whole company before, now at Airbnb, it's a little bit different. We have a lot more iOS developers, and this is not actually the whole iOS team. And I moved from actually interacting with people in this small subgroup to actually support people in all these different teams, which means like everybody has like different priorities and different goals because they're part of different teams. So this was definitely a big change and very different for me. And there's a quote by Melvin Conway that says, organizations are constrained to produce designs which are copies of the communication structures of these organizations, which basically means, for our case here, that the code base actually starts mimicking your organizational structure. So how do we divide our code base? When I worked at startups, one of my approaches was originally doing by kind of like architectural layers. So I will have like a coordinators layers, interactors, view controllers, presenters. You can see I was like very influenced by clean architecture at the time. And then when like the startups actually started growing, I started seeing something like this, more based on like user flow. So you can imagine like at Airbnb, like a booking user flow, like a wish list user flow, listing user flow. So what about Airbnb? How do we do it? Well, the Airbnb code base, the first commit to the Airbnb code base was actually in 2010. And right now, we have more than 1 million lines of Swift code. And we get around 80 commits on any given day to master. This is actually Android and iOS because we have a monorepo for both platforms. So we created bigger buckets. So instead of groups, we actually have modules. But you can see here that we have like different things. We have something that is called networking which is kind of like an architectural concern. But then we also have booking or wish list, which is more kind of like a user flow. So my guess is like at one point in 2010 or wherever, we actually went in that one direction, then we went in another direction, and we ended up with like this mix of things. So let's think about this use case that is going to use these modules. Let's think that we have a use case when we want a user to be able to wish list a listing from the booking flow. So how do the modules that I showed before relate to each other? We can imagine booking the booking module actually depending on the wishlist module, and both of them depending on networking because they need to like do some endpoint, an API to an endpoint. But you can imagine that booking actually also has more features, right? It has more capabilities than only wishlisting something. So you can imagine booking actually depending on help center, or like a business travel, or like a listing to actually show the listing flow. And all of these things most likely depend on a very low-level layer, like networking. So let's think for a second what happens when we modify something on the networking module. So if we modify something on the networking module, that means that that module will need to be rebuilt. And then every dependency to that module also needs to be rebuilt. And this is like an extremely simplified version of what was actually happening at the Airbnb app. So at one point, we were actually experiencing 50-minute local clean builds, which means you click on build, and it takes 50 minutes to launch the simulator. This was obviously a problem. So the first thing that we did, we basically got bigger hardware, bigger machines. And this actually reduced our build times by a lot. We went to the 30 minutes. But still, 30 minutes, not the best experience for our developers. So we did another thing, and we tried to tackle this problem with software. And we actually changed Xcode build as our build system to use back. And actually, if you were here in the morning, Keith actually talked a little bit about Bazel. I'm not going to go too much into detail what back is, because as we saw in the morning, you can have like a whole talk only about this. But like one of the things that you need to know is that we have the option now to actually have a cache on the network that we can download, and instead of like building and compiling the whole app, we can actually download this cache. And this actually meant that for us, we moved from something like 30 minutes to actually 5 minutes using back and the cache. And this is pretty good. But this is still a lot of time waiting for Xcode to finish building. So let's go back to the original diagram, and let's think about this. So I will say that there's something inherently wrong here. And that is that we're depending on too much code. So let's think how we can actually figure out how to split this better. There's a principle that is called dependency inversion principle. Again, solid, Uncle Bob, I know, don't judge me, but I like it. So dependency inversion principle, for the people that are actually not familiar with this, states that high-level modules should not depend on low-level modules, and that abstraction should not depend on details. So what does this mean in practice? In practice, it means that we create an interface module that basically just have like a very thin value type or like protocols. And then instead of like having everybody depend on the concrete type, which is networking, we depend on this interface, and networking will actually implement this interface. Let's go back to the original use case. A user should be able to wishlist a listing from the booking flow, right? And we have this. We have booking depending on wishlist. But actually, booking doesn't need to present the whole wishlist flow. It just needs to actually be able to wishlist a listing. So how we can split this? Well, we can reuse the same principle, right? We can just like create a module with this interface, and then have everybody depend on this module instead of like depending on the whole wishlist user flow. So booking depends on less things. It doesn't depend on the whole user flow. So we go ahead, we create this is a great idea, but there's one little problem here, that the wishlist data source, the concrete implementation module, is actually still visible for everybody to use. So actually, you can still do this. There's nothing preventing you from depending directly on the concrete implementation, and this is something that we don't want. So how do we solve this? Well, we socialize this with best practices. We socialize the best practices. So basically what this means in startups was getting together, booking a room, and talking to other people that were the other iOS developers, and convince them that this was a good idea. But when you're actually developing an app and supporting more than 60 other iOS developers, this doesn't really work. This doesn't scale. So we need to automate these best practices. So how do we do that? So we said that we had these groups at the beginning, and then we created like a bigger bucket that was modules. So we actually came up with like a new concept that are module types, which are basically a bucket of modules. And we have two types of modules, a feature and a service with their corresponding interfaces. What is a feature? A feature is a screen or a flow in the app. So basically, you can imagine that a product team will start with like only one feature, one module, and then when actually other people start depending on parts of that module, you actually split them up into like more smaller modular modules. And then services are a way to manage shared state or resources. So if we go to the modules that we were discussing before, you can imagine booking, wishlist, and listing being features, while services are networking and this wishlist service. And you will have like a corresponding interface for each one of these. So how do they communicate with each other? So these are the rules that we came up with. Basically, you have a feature that can implement a feature interface and a service that can implement a service interface. But as you can see here, actually, features cannot depend directly on services, and feature interface cannot depend directly on services. So this is the thing that we were talking before that we want to enforce. So how do we enforce these best practices? Well, we created folders inside of a repository. So we have a services folder, service interface folder, and features folder, and feature interfaces folder. And basically, inside of each of these folders, the modules that correspond to these types will be there. So one folder per module type. And as we were seeing before in Keith's talk, we actually also have like a way to define a module. So we have a method that is called a service interface method that has an input as name and dependencies. And then inside of this, this method, the implementation, so this is like obscure to the user, actually has a maximum visibility rule. So this tells you what folders, what modules in what folders can actually depend on service interfaces. So if you have a module inside of feature interfaces, this tells you that it's okay to depend on service interfaces. And when you're actually using this as an actually user of the platform, you get this. So basically, you call this method with the name of your module and the dependencies of your module. So this is creating the networking service interface. And for our use case, that we were talking about booking before, we will create the same, but for a feature. So it will be the name booking, and then the dependencies will be networking and wishlist service. If we were to actually add a service here, not a service interface, but a service here, this will actually fail when we're generating the project. So this is what we call the iOS platform internally. And we're creating a lot of modules. So we need module creation to be easy. And before we actually did all of this, module creation was a process that was kind of like this. So you have to follow a manual that basically told you what things you had to do and what things you had to remember to not do, because if you do something wrong, the app could crash. So this was like obviously not ideal, very error prone, so we wanted to do better. And the worst part of this is the output of this was actually something like this, which when people saw it was like, well, yeah, okay, stamped, that's okay. No one was reading this, no one was understanding what was going on here. So instead of that, we actually automated this process by creating a script. So right now you call rake make module, and this will actually ask you what module type you're creating, what's the name of your module, and actually what's a small description of your module too. And this is all possible, again, because of Bug. Because Bug gives us human-readable dependencies. And I know that I'm not talking a lot about Bug here. We actually have a couple of talks about that. But we also open source our usage of Bug in github.com/Airbnb/bug sample. So if you're curious, you can go there, you can create an issue, create a pull request, and we'll get back to you. So, and how does this look right now? So when you're actually adding a new dependency, you basically just add a one-line change to your module declaration, and that's it, instead of having this huge diff with a lot of things that you were not understanding. So the end result looks something like this. So you have booking depending on all of these other interfaces, instead of like depending on concrete types. And let's think for a minute now. So we said that a feature is a screen or a flow in the app, so it has an entry point. So since it has an entry point, now we can do something fun, like creating an app delegate that is completely fake, that we can use instead of like building the whole workspace, we can build a tiny workspace instead. We obviously need to like fulfill the dependencies, so we need to inject both the features and the services. But since our dependencies are now protocols, if we don't care about some of them, if we don't care about iterating in the help center feature, we can just mock them. And this makes it way faster. This is a concept that we internally call dev apps or development apps. And this actually got us to around 1 or like less than 1 minute clean build times. So we created these big buckets, but we keep small playgrounds for developers to work on. And this all sounds really good. But there's one thing that you have to consider too when you're working on a big company supporting a lot of people, is how do you get there? How do you migrate to get to the endpoint? So before we actually started this whole process, we had around 100 modules. And we had one monolithic module type. So all the modules that I was referring to before, like booking or wishlist or networking, they all live in the library's module type. This was before the iOS platform that we now call a legacy module type. So on the iOS platform, we want people to actually move to all these other folders that have stricter visibility rules and stricter dependency rules. So how do we get everybody to the iOS platform? One option, which is the option that most developers would like to do, is just remove completely everything, every code that we have in the app and start completely over. This is obviously not possible because we cannot stop development just because on an infrastructure team we want to re-architect the app. All these other teams need to continue working. They have different priorities. They need to continue shipping new features. So we cannot do this. We need to progressively migrate to the iOS platform. So let's go back to our original example, and let's migrate together the wishlist data source. So as I was telling before, we had this wishlist module that is in libraries, and that has both the wishlist user flow, but also all these responsibilities with networking and all these things. So we had this, we had like booking depending on the whole thing, but we actually wanted to split it into like a separate part. So this is what it looked like, right? So we had on one side all these modules that are still part of libraries, booking, wishlist, and networking. And then we have these new modules that we're just creating to move code to the iOS platform. So wishlist service, the interface, and the concrete implementation. So this is as a reminder, the platform dependency rules. So features can depend on feature interfaces, services can depend on service interfaces, no one can depend on service, but there's obviously now one big piece missing here, which is what are the dependency rules for libraries. So there are two main types of dependency here. We have inbound dependencies and we have outbound dependencies. So let's start with inbound dependencies. What do I mean by that? Inbound dependencies are basically things that come inside of the iOS platform. Basically, everything here that is depending on wishlist service interface. So we have booking and wishlist depending on the service interface. Let's remind for a second why we're doing this. We're doing this because we want actually better boundaries. We want stricter rules on our dependencies. So when we're actually creating these interfaces, we're just not creating a one-to-one mapping to what we have. We're probably going to refactor a couple of things and create a better contract for our customers. Which means that if we want to migrate this wishlist service, we'll need to actually migrate all the call sites at the same time. And the call sites are things like booking that we actually don't control because that's probably another team, and we don't really know how they're using our dependencies. So it's pretty hard to actually migrate those ourselves because we're not familiar with the usage of that module. And obviously, the problem with allowing these dependencies, these inbound dependencies to the iOS platform, is that we're allowing this tech debt that we're actually trying to solve in the first place. But I will say that this is actually calculated tech debt because we actually had this problem before the iOS platform. So even though we're still continuing to have this problem, we can allow this. So we decided to allow libraries to depend on the iOS platform. And let's discuss outbound dependencies now. So outbound dependencies, obviously the opposite of what we were discussing before, are things that come from the iOS platform to libraries. And these are kind of like the opposite that we were discussing before, because we know our usage of the networking library because it's our module, so we know what we're doing with it. We're familiar with this. And we can control what we depend on. So it's a lot easier to actually change these things. So we decided that we were going to allow inbound dependencies from libraries to the iOS platform, but we were going to restrict outbound dependencies from the iOS platform to libraries. So libraries actually has access to everything, which means that the iOS platform doesn't have access to libraries in the other direction. So code on the iOS platform, we still keep like the good boundaries that we wanted to enforce at the beginning, while still allowing for an easier, more smooth migration path for everybody. And how do we do this? Basically, when we're implementing the service interface method, now we call this add visibility for legacy module structure method, that basically, it's really simple. It basically extends the array by adding libraries as an allowed module that can depend on you. So we started migrating from the bottom up, because in our example before, you saw that wishlist actually depending on networking, but that's forbidden now. So we needed to actually start migrating the things that are on the lower layers. But since this is coming from an infrastructure team, we're actually the owners of a lot of these modules. So this forced us to actually try all of these rules on the iOS platform ourselves before we actually open it up to other pilot teams that were more features or more product-oriented. And you're probably like thinking right now, should I be implementing this in my own team? And I will say most likely the answer is no. As I pointed out at the beginning, each organization affects how your code base is structured, and each organization is different. So there's no real silver bullet that is going to work for everybody. This is kind of like what software engineering is. It's basically taking a bunch of requirements and then creating an output from them. So even though this works for us, because this is how our organization is structured, it makes sense for us, I don't think this works for everybody. So I'll recommend you to innovate and adapt these ideas into your organization instead. So to summarize, figure out where you're struggling, create and document best practices, and then automate those best practices. Gracias. So 2 things before we go into questions. My slides are there. And if you want to ask anything in Spanish, I'm a native Spanish speaker, if you didn't tell by the accent. So feel free to ask anything in Spanish.
OK, anyone? Questions? Don't be shy, don't be shy.
If you want to go grab a beer too, that's also fine.
Someone there?
I'm also going to be around if anybody wants to.
We have one here.
Go ahead.
It must be in Spanish, or I can...
Someone said it in español, así que...
Ya, está bueno.
I can translate afterward if you want to.
Ok, Mackey. A ver, creo que cuando hablaste de cómo habían estructurado todo el código que utilizaban en las interfaces del feature y de servicios, nunca mencionabas si, o no sé si no me di cuenta, pero ¿todo este código era parte del mismo proyecto o lo importabas como un pod, como lo hacían, por ejemplo, en Mercado Libre?
Yeah. Should I translate before the question? Yeah, so the question is basically if we have everything in the same project, or if we use like CocoaPods or something different where we have like different repositories to actually fetch the code. We actually have one monorepo where we have all the code there. So all the code is in the same project at Airbnb. So we have one repo which actually has all the iOS code and all the Android code.
¿Y cómo evitaban los problemas que principalmente querían solucionar en Mercado Libre, Mercado Pago? Que era el tema esto de trabajar con muchas personas y los merge.
Yeah. So the question is basically if we had like the same problems as Mercado Libre, like the talk about modularization before, where we want to have like different people working on different parts of the app. So I think like these approaches are kind of like similar. So you can actually like take like the project completely out and put it in another repository, or you can create like small modules. So as I pointed out before, you have like all these kind of like folders, and inside those folders you have like small modules, right? So when you're like working on a feature module, you will just work on that small project, and these modules actually translate to like Xcode projects. So you can just like work on that little project, iterate there, and then just like merge what you need. Does that make sense?
Kind of.
And then it's always like a trade-off, right? Like if you have like all these CocoaPods project, it's like a little bit harder to actually iterate because you have to like maintain like semantic versioning and a lot of other things. So it depends on like what your structure is, and that's why I keep back like of like what I was saying. Like there's like no one solution, and this solution makes sense for us because like we again like have everything in the same repository, and we share a lot of more things. So in the example of like Mercado Libre, you have like all these like repositories that are like very hard to share code between each other. And for us, that's like a pretty common use case, like sharing things between like feature modules. And that's why we need like everything in the same project, in the same repository.
Oh, ok. O sea, me imagino que si el Juanma de Mercado Libre, tú, el amigo de Nubank, trabajaran juntos, serían como los Vengadores de iOS, una cosa así. Bueno, gracias.
Well, anyone else?
Sí,
Yeah.
sí, también. Pancho. Oh, me cagaron.
Hi, thanks for the talk first. And I had a question about every single time you add a new model, if you are a dynamic model, you're increasing the launch time, exponentially if you have end models. So how do you deal all these timing in the launch time of the application?
Yeah. So if you launch the whole Airbnb app, well, first, we don't use frameworks, dynamic frameworks. We use static libraries. If you actually look at the slide where I was like showing like the first couple of modules, those are all static libraries. So you don't incur into this dynamically loading upfront cost. But there's still like if you open like all these modules at once, there's going to take a couple of seconds. And that's why we're kind of like moving into this direction of having like small playgrounds where you just like develop in your little playground instead of like having to open the whole Airbnb app, because that's indeed like a costly process.
Okay, here, one more.
Yeah, Pancho. 1, 2, 1, 2. Muchas
I
gracias.
think there's someone there.
Okay.
Go ahead.
Aquí. Yeah, thanks a lot for the presentation. Look, my question actually about the monorepo, not about the architecture. How many open pull requests do you have all the day, and how do you control all this stuff? Because I imagine, for example, you have like how many modules, so it could be a nightmare.
Yeah, that's actually a really good question. And one of the things that I actually removed from the presentation was one of the things that actually answered that question. So since we have all these modules, when you're creating a new module, one of the things that I took out of this is actually asking for the owner of the module. So each module actually has a specific team that needs to be a team and not an individual. And that team is actually connected to like our backend that we have that has like a list of all the teams available at Airbnb. So when you're creating a module, you're forced to actually assign a module to a specific team. So each time that you change code in one module, that the team that is the owner of that particular module needs to actually talk to you and review your code. How do you solve that? Because like as you pointed out, like it's pretty hard to like review like hundreds of pull requests a day. So what we're trying to do is actually enforce more interface modules. So when you have like a contract there, it's actually way easier for people to plug into that. And when they actually need a new requirement for you, they actually need to talk to you, and you will change the interface or add something to the interface or modify it and then implement what they need. So in practice, we're trying to like contain the amount of pull requests that we review by having like very explicit ownership of each of the modules that we have.
Thanks.
¿Aló? Es acerca de los monorripos y back. Es verdad que para usar back tengo que usar monorripos, y también sobre la infraestructura. Cuando es verdad eso de que entre más para hacer builds paralelos y todo esto, tienes que tener mucho poder de máquinas buenas.
Okay, so there were two questions, right? Like first, if you need to use a monorepo to use back, and the second one was if you have like a large code base, do you actually need like all this power, machine power, to actually process this? So the first one, I'm not an expert on back, but I will say probably not. Like we actually had different apps smaller apps that we have inside of our project. You could actually fetch dependencies from outside. We actually have a system that like fetches dependencies, and we actually also use CocoaPods to download dependencies. We don't use CocoaPods to generate the project, but we do use CocoaPods to actually fetch dependencies. So you can actually do whatever you want. You can create like an external repository that where you have like other dependencies and pull those into your project. So you can do whatever you want. And then one of the big things about like how expensive it is to build these things is that the bigger you can parallelize all this module compilation, the better, right? So if you need, in my example of like booking, depending on wishlist, depending on networking, in that case, you need like booking and wishlist will actually need to wait until networking completes building before they can actually start building. So if you can actually parallelize that by not having like strict dependencies and having like these interface modules, and there's like smaller things too, you can actually make it way faster. And we actually have like a pretty good tool in back to actually see how these things work. So we can actually inspect and see how many like cores are being used right now in a single moment to see how parallel the process is. So if you can parallelize this better, it's way easier for the machine to actually do it. But like better machines obviously are going to produce better results.
Well, thank you very much, Francisco.
Thank
A big
you.
clap for him.